In my first video on curve sketching, I'm going to look at quadratics. Now I've got a couple of videos already on quadratics, completing the square and solving for x-intercepts. In this video I just want to concentrate on a quick way of drawing a sketch for a quadratic or a parabola, which the graph is called. If you can factor it, and that depends on how easy this is to factor it. But if you can factor it, then you can easily see the x-intercepts. Because if y is 0, x is either 5 or -1. So the intercepts are 5 and -1. And then you see, we're looking for the line of symmetry, which is halfway between the -1 and the 5. And you can do that simply by counting along the x-axis. Or a more formal way of doing it is to do an average, add the 5 and -1 together and divide by 2. And once you've got that 2, you can substitute it back into either this line or that line. It really doesn't matter which one you go back to, and get the y value. The other way you can do that is because the coefficient of the x squared is a 1, this parabola has a normal shape. By normal I mean it's like the y equals x squared. And you see, once you find the vertex, if you go over 1, you go up 1. If you go over 2, you go up 2 squared or 4. If you go over 3, you go up 3 squared or 9. So that means if I'm 3 units from the line of symmetry, if I just count down 9, I would find that y coordinate for the vertex. So you can actually do it algebraically by going back to either one of these lines, or you can simply just do it by counting. Now, if you can't factor, there's a nice easy way of getting the line of symmetry. Because if I let y equal -6, the reason I'm putting in -6 is so that when I bring this -6 over, I get a 0. And this is easy to factor. I can factor out a common factor of x. I've got x minus 4, which gives me two x values, 0 and 4, which give me a y of -6. So once again I have 2 points that are equally spaced on either side of the line of symmetry. I can average the 0 and the 4 and again get 2. And once again, substitute that 2 back into the original to get -10. Now to show you this on a diagram, what I've got is the 0, -6 and the 4, -6 are here. And you see how they're equally spaced on either side of the line of symmetry. So all I have to do is count. If I wanted to do this without substituting the 2 back in, all I have to do is say, these points are 2 units from the line of symmetry, so if I come down 4, I would be at the vertex. And to get another point on the graph, in order to draw it, again, because this is a normal shape, by normal I mean same as y equals x squared, if I go over 3 units, I would go up 9, and I would have 2 more points to use to draw the graph. And as you can see, where I'm crossing the x-axis here, those are not rational numbers, since this was not capable of being factored. If you wanted to know what those numbers are, you'd have to use the quadratic formula. Let the y equal 0 and use the quadratic formula on that. Now, my last example has a -2 in front of the x squared. Now, that tells me that the parabola is going to open downward and it will move down at twice the rate. So if I, just like the last one, I'm going to put a 7 in for the y on this side. When I move that 7 over, I have a 0. I can factor out -2x, and that gives me 2 values, 0 and 4. And both of those values, 0 and 4, give me a y value of 7. And those are the 2 values, 0, 7, and 4, 7. This is where they are on the graph. And you see, once again, I look for the line of symmetry. It's halfway between 0 and 4. Just average the 0 and 4, you get 2. Now, you can either plug the 2 back in here, and you will come up with 15. Or you can do this. You are 2 units from the line of symmetry. With a normal graph, like y equals x squared, you move 4 units if you move across 2. In this case, we've dropped twice that. We've dropped 8 units. So if you go up 8 from that 7, you will have the vertex. And then to get a couple more points, again, you can use the idea of if I go over 1, I go down twice 1 squared. In other words, I go down 2. If I go over 2, rather than going down 4, I go down 8. And if I go over 3, instead of going down 9, I go down 18. And this is what the graph looks like. Vertex here at 215. These were the 2 points that I started with. Also notice that the number on the end is always the y-intercept. So as soon as you look at this, you can tell the shape. It's opening down at double the normal rate. Y-intercept for 7. And use the procedure that I gave you, and you can draw these fairly quickly.